Good morning to all. Myself, Dr. Arun from Aerospace Engineering Department. Today, I am going to take one topic from Aerospace Propulsion subject. Topic name is analysis of nozzle and propellant types. So, in that things, I am going to elaborately discuss about the nozzle types and propellant types. So, in that empathize part, what are all the mission requirement for these cases? The first one is payload. Second one is I'm going to take the delta V rocket, and next one is the duration. So, in that payload, the how much weight it will be carry for the cases, and delta V here the water all the propellant or propulsion system they are using, and the duration how much it will be traveled from these cases. And next one is from mission point of view, match the engine to the job. So in that cases, we will check the following cases. First one is the vacuum, atmosphere, or both. And second one is the how thrust it will be founded, and how long it will be fly in that cases. And next one is restart, throttle, and simplicity. And the next one is safety, cost, and reliability. And that different porters, it will be depend on the D level nozzle. This is the baseline. So in the D level nozzle, it can be used for the converging section. So it will fly. It will run at below Mach 1 conditions. It will be directly accelerate the vehicle there in that supersonic speed. Next one is the types of nozzle. So in that types of nozzle, it can be classified into three types. First one is a conical nozzle, well nozzle, and a aerospike nozzle. So in that conical nozzle, if the characteristics are very simple and robust and lower, it provides a very lower efficiency. But next one is the bell nozzle. Compared to the conical and aerospike nozzle, the bell nozzle gives the higher expansion efficiency, and the third one is the aerospike nozzle. So in that aerospace nozzle, it gives more altitude and provide a good performance compared to the conical and bell nozzles. And ideate part, the propellant comparison. So generally the aircraft propulsions are, it can be classified into three types of. First one is a solid, liquid, and electric. So in that solid, if the construction is very simple, and solid propellants are storable inside the rocket engines, and next one is it provides a high thrust. Next one is a liquid propellant. So in that liquid propellant, it gives a more efficiency compared to the electric and solid. So last one is a electric propulsion. So in that electric propulsion, it have a ultra high specific fuel, uh, and it gives very low thrust compared to the solid and liquid. And next one is what each propellant gives you. For example, by using the solid propellant, it gives the boosters, a rapid burn, and limited controls only. So in that liquid propellant, we are using the LOX and LH2, CH4. These are all the liquid gases are used for these cases. For mono propellant, here we are using for the simple spacecraft controls only. And for electric propellant, it gives a deep space efficiency. So by the comparative stages, the high thrust it will be produced in that liquid propellant, and complexity it will be given for this solid propellant, and maximum ISP it will be produced for this electric propellant. This is the comparative of solid, liquid, and monopropellant, electric propellant. Solid gives a higher thrust and low efficiency. By using the liquid, it gives the high thrust, medium efficiency, and monopropellant they have used for the thrusters only. It gives very low thrust and medium efficiency. For electric propulsion, it provides a low efficiency and efficiency, high efficiency and low thrust. So these are all the cases. It will be drawn for that cases for deep space. The low thrust it can be found for upper stage. The high thrust it can be found for launch booster. The thrust is very high, but efficiency and complexity is very low. So these are all the comparative study we have discussed in this video. So we will catch you on next video on next topic.